Today we're going to learn about electrolysis and electroplating. And for electrolysis, this is where we force an otherwise non-spontaneous reaction to take place by passage of a current through a liquid or solution. So what we're going to do is we're going to look at a normal voltaic cell where we have our zinc electrode breaking down and forming zinc 2 plus and generating some electrons. So the electrons are going to travel from our zinc across through our wire, through our voltmeter or device of our choosing, down through the copper electrode, where it's going to interact with the copper sulfate solution, and then cause it to plate onto our electrode here, or onto the copper electrode. Now, for this, we designate that the electrons are coming from the anode, and they're going to the cathode. All right, and then with our salt bridge, we're going to have our chlorine ion, the negative ion, or anion, going towards the zinc sulfate solution, and we're going to have our sodium plus, our cation, going towards the copper sulfate solution. It's going to be following the electrons. So this is how a normal voltaic cell works. Now for electrolysis, basically what we're doing is we're no longer powering a device, but we're getting power from something else. And this can be a battery or just some sort of external power source. But the main thing here is that we are going to be providing electrons from our battery. So now the electrons are going to be coming out of our negative terminal down through our zinc electrode, and then that's going to cause it to interact with the zinc 2 plus, where we're going to be forming zinc solid onto our zinc electrode, so plating it on there. And then we're going to have the reverse happen on the copper side, where we're going to be having the copper break up into copper 2 plus and generating some electrons as well, so that we will essentially have it be coming back towards the battery. Now, all this is possible if we have a voltage that is above the spontaneous cell potential of the voltaic cell. So for the voltaic cell, when we hook that up to a voltmeter, we got out 1.10 volts. And so our battery now has to have a higher potential than that, it has to have a higher than 1.10 volts. So provided we have that external power source that is above that range, we can make this otherwise non-spontaneous reaction take place. And so this is essentially the same process that is used for charging batteries. Batteries are essentially voltaic cells, and by reversing the process with the external power source, we can essentially recharge or reverse that spontaneous reaction so we can save it for a later time. So now what we're going to do is I want to show you guys a little bit about electrolysis, where we can use electrolysis to kind of essentially use it for purifying things or for making new substances. So for that, we're going to take a look at water electrolysis, where we have a battery hooked up to water. This is mixed with sulfuric acid. Basically, the sulfuric acid is serving the purpose so that electrons can travel through our solution. But as this is taking place, the electrons are going to be provided on one side, on the negative terminal, where we are going to be generating hydrogen gas. So that's going to be converting that acid, that H+, and adding electrons to it to generate H2 gas. And on the negative terminal, we are going to be essentially removing electrons, and this is where we're going to be generating that acid, the H+, and 4 electrons. And while doing this, we essentially free the oxygen from the hydrogen. Now there's one correction here. This should be 2 waters. But as long as we have a power source that is providing a voltage higher than what this is, so right now this is at negative 1.23 volts when we add those two together. So as long as we have a power source that has above 1.23 volts, we can actually have this reaction take place. Now this is a fairly typical setup for collecting various oxygen and hydrogen gases from water. One of the key things on here is that we can see that we have some valves here, so we can go through and collect our gases fairly easily, and you can keep on adding in more solution as you're using up your water. But electrolysis is used for a whole host of ways of collecting various compounds, but water electrolysis is probably one of the easier ones to do because the starting material is not too bad. Now, another thing we can do along similar lines with electrolysis, so with this one we can see that they're all in the same vessel, and normally for these electrodes we'll use something like platinum because we don't want it to react and have some side reactions or be consumed. We just want something that won't essentially get dissolved by the sulfuric acid or corroded. Kind of in a similar vein, this is how we can do electroplating. So electroplating, for electroplating, we want to go ahead and get some solution that we have. So in this case, this is a copper plating setup where we're going to have our part, in this case a stainless steel washer, hooked up to a negative terminal so that the electrons can travel down through to our part. So electrons are going to be provided down to our part, and as the electrons interact with the copper, or copper sulfate actually, that will generate solid copper, and so it will be plated onto our desired part. Now the other thing that occurs here is as this reaction goes on, our copper is going to turn into copper 2 plus 2 electrons. And so as we're losing this copper 2 plus to be plated onto our part, some of the copper in this copper electrode is going to be dissolving into our solution to maintain its molarity or to maintain its concentration. And so this is kind of an ideal setup for electroplating. Normally you want to have whatever your positive terminal is, or your anode, whatever your positive terminal is, to be the same as what you have in your solution and what you're trying to actually plate with. Now, for other setups, it can be a little bit more complicated. So again, to kind of highlight, for this one, this is a very simple one. Normally this can be done for a whole host of metals without any lot of pre-treatment. One thing that you can do to make your electroplating process better is normally you want to make sure your part is nice and smooth, very well polished. Because if it has a lot of defects, those defects are going to show up with the plating process as well. And sometimes that results in essentially micro cracking, which makes the part look pretty dull and non-lustrous. But again, with copper sulfate, there's not a lot of side reactions that can take place. Now, for other processes, like with chroming, it's not as straightforward of a process, and there's other things to be considered. So similarly, we need to hook up our part to the negative terminal, and then the electrons will travel down to your part and interact with the chromium to eventually turn it into solid chromium, and essentially putting a thin layer of chromium on your part, or better known as chroming your part. And this is one pathway that this can occur, but one thing that happens with chroming is there's a lot of other possible side reactions that take place. And with these, some of them are desirable. You still end up with solid chromium, but with other ones you end up with other solids that maybe are less desirable. So in order to counteract this, normally your parts have to be pre-treated Certain metals work better for adherence to get the chromium to stick onto there. And a lot of times we'll have to add catalysts. So one of the catalysts would be sulfuric acid. The sulfate ion will help speed up the desired reaction. Also adding some fluorosilicates will be used. And one of the other things is you'll notice we're not actually using a solid piece of chromium here. We're using lead. And lead would help prevent some essentially nasty side reactions from taking place, or at least minimizing their effects. So whenever you go through and you're trying to do any kind of electroplating, it's normally a good idea to look up some of the literature or see what has been done so you have a better idea of the process to use, because honestly each one of them is a little bit different. So say for the copper situation, when you're playing with copper, normally you want to use about 1.5 volts, something around there, so that it will plate slowly. You also want to use low current so that as it's plating slowly, you get better surface adherence. You may want to bump it up to 3 volts as kind of like a pre-treatment and wipe away that copper and then essentially plate it again. But for chromium, what they do for that chromate solution is normally it's put around 12 volts because you want to speed up the desired reaction and not get a lot of those side reactions. So again, it kind of depends on the setup and what you're trying to chrome with, or what you're trying to plate with, and what you're plating onto. So again, in the case with chromium, you may want to coat your part with a different metal first, such as nickel, possibly zinc, something like that. Whereas, with the copper one, you can do that for a lot of different materials. So with that, I want to actually show you guys some electroplating. And so I'm going to bring us over to a little demo where we're going to be doing the copper plating setup.
All right, so we have our electroplating setup. Here we have some copper wire. We stripped off a little bit of the shielding so our copper will be exposed. And we have one that has a little hook shape in it. This will help us to put on our object that we wish to electroplate in just a second. We are going to be electroplating a little washer. And you can see that this is kind of silvery in nature. And we're going to be putting this into a copper sulfate solution. Now, one of the things with this is you want to make sure that you always set up your negative terminal onto the part that you wish to electroplate, because you want to make sure you put your object or your material you're electroplating onto your part as opposed to destroying your part. So I'm going to turn this on so we can go ahead and get this started. So right now I have it hooked up to a DC power supply, and you can use a battery or whatever you want, but you just need some sort of voltage going to your part. So I have it set up right now to 3 volts. This is probably a little bit too high for true electroplating, but we'll probably get a pretty good adherence on our surface all the same. And then, so this is providing electrons to go down through our black wire from our negative terminal down to our part. And our part is going to be gaining those electrons. Now on the surface of our part, it has all these extra electrons. And so the copper 2 plus of this copper sulfate solution are going to start adhering onto our surface of our part. And so this is essentially what is electroplating. Now this is the same process that can be used for chroming things. So if you ever want to get your car nice and fancy, you want to chrome a bumper, or let's say you want to chrome your wheels, this is the exact same process. They just use a chromate solution. All right, and then on our other terminal here, to keep our solution at about the right concentration, right now we're at about 0.5 molar copper sulfate. We have it hooked up to some copper, and so this is going to allow some copper 2 plus to be coming off of our copper rod here. So let's go ahead and take a look at our part. And I'm going to go ahead and wash this off a little bit because it has a reasonably high concentration of copper sulfate. All right, that should do it. We'll go ahead and turn this off. And we should be able to see that we have a nice coppery color on most of our part. We can go ahead and wipe down part of this, and a little bit of it's probably going to come off to some degree, but not a whole lot. And we still see that it is fairly copper color in nature, so we have a nice copper plating on here. Now we could give it a little bit longer, and that would make it deposit more copper onto our surface. But this is essentially how you do electroplating. So you want to make sure you always have a power supply of some form, be a battery or a DC power supply, and you're providing the electrons are hooking up to the negative terminal on the part that you want to electroplate. Anyway, I hope you found this useful, and look forward to seeing you in the next video.